Hi, welcome to strings and memory allocation. The most important topic regarding interview. Okay, the most important topic, you should never miss it. Okay, you'll find one or two problem from memory allocation definitely in the interview, definitely. Okay, so let's see it. Fine, we will see further the tricky problems. Okay, how you can solve those problems using memory allocation. Okay, so let's see it. Now, very first thing is you can create strings in two ways. In two ways, okay. The first way is direct literal way. Second is using new operator. Now you will be asking what is the difference between them? Okay, what is the difference between them? Memory allocation is the answer. Memory allocation. Let's see it. Okay. We will further see. That's a very interesting topic. Okay, and then I'm gonna tell you the great real world example. Okay, if you understood that example, then you will never forget memory allocation. Fine. So you can create the strings in two ways. The first is using direct literal. Okay, using direct literal. Okay, what it is? String a equals Yash. Okay, suppose my name using direct literal. Okay, second is using new operator. String b equals new string Yash. Okay, now if you print the output, if you print a and b, you will get the same value. Yash. Now you will be asking like what is the difference? I told you na. Memory allocation. We will see. It's the most interesting and most important topic. Okay, and the great real world example you should understood. Fine. So this is the two way we can create the strings. Fine. Now, now rule number one. Rule number one. The most important rule. The most important rule. Okay. RGB. Fine. Actual value or actual object is going to store in heap memory. The most important point, actual value or actual object is going to store in heap memory. Fine. So now there are two type of memories. One is stack memory, one is heap memory. Stack and heap memory. Fine. So rule number one is actual value or actual object is going to store in heap memory. Okay, what it means? What it means? Let's see. Suppose I have created a string using direct literal. String a equals Yash. Okay, and now I have given you a task that draw a memory allocation graph. Fine, okay. Stack, heap, stack memory, heap memory. Fine. Now I have told you that actual value or actual object. What is the actual value or actual object here? Tell me. Yash. This is only the actual value, right? What is the actual value? See, this is a keyword. This is a class. It is a variable. What is the actual value or object? Okay. Yash. So it is going to store in heap memory. Remember this thing. Fine. And reference variable is going to take place in stack memory. Okay. And it is pointing to the value. When you call A, okay, when you call A is pointing to the value. Yash got printed out. Okay. This is the concept one. Okay. I am not talking about primitives. I am not talking about primitives. Okay. No. Primitives are going to store in stack memory. I am talking about non-primitives. Fine. You'll see primitive later. Fine. It is not so important. You'll get a question from non-primitives. Fine. Okay. So this is you got clear. Fine. That actual value is going to store in heap memory. Fine. And this is the memory graph. Okay. Now your next task. Your next task is, suppose I have created a string A is equals yes, okay, and string B equals same, yes. Yeah, I can create. There are two different variables with the same value. Now draw the memory allocation graph. Pause this video, draw it. Drawn? Okay. I hope you all have drawn like this. A, okay, A is the reference variable going to take place in stack. This is a stack memory. It's a heap memory. And actual value is going to take place in heap memory. Fine. Similarly for this, B, an actual value in heap memory. A is pointing to this, B is pointing to this. Fine. According to this rule, actual value and actual object is going to store in heap memory. Okay. Two actual values are there going to store in heap, and two different reference variable take place in the stack memory. But this is absolutely wrong. Wrong. Why? Why? Okay. Let me tell you why. So, answer is a string constant pool. What it is, let me show you. Okay, concept. When you create a string using direct literal, okay, direct literal, then a string is going to store in a string constant pool memory, which is present inside heap memory. String constant pool. Okay, now suppose I have created strings using string A equals yes and string B equals yes. Fine. So what is the correct memory allocation graph? Stack heap. Just see carefully. Okay. When you create a string using direct literal, okay, direct literal, then string is going to store in string constant pool, which is present in heap memory. Simple. This is a string constant pool. Okay, a string constant pool. And if you create the string using direct literal, then those values are going to store in it. Okay, fine. So now you will be asking like, fine, let us store yes here. Okay, and yes here. Okay. According to this definition, when you create a string using direct literal, then that string is going to store in a string constant pool. Now you will be asking, then why this is wrong? Okay, there is another constant pool. Okay, but that constant pool is in the heap only, na? It is inside heap memory, stack and heap. So what is the requirement of this string constant pool? Okay, so the correct memory allocation is A pointing to Yash, B pointing to Yash. Fine. If you create strings using direct literal and the values are same, then it will not create the copy of that values. Only one value. And all the different reference variable pointing to that. Okay, are you ready for the great real world example? Ready? Just first see this. This is the mistake. Okay, only if you create the string using direct literal. Fine. Direct literal. Direct literal means direct double quotes. Okay, see the values are same. Yash, yash. If you create using, okay, fine, string C equals yash, D equals yash, E equals, then here C, D, E and pointing to the same value. Get your point? If the values are same, it will not create another copy. It will not create, it will not take another space. It is highly optimized. Okay, good. Now, ready for the great real world example? The great real world example. Okay, consider this is me. Me. Okay, yes, this is me. Okay, my friends used to call me Yash. Okay, my friends used to call me Yash. Okay, my sister used to call me Yash. Okay, or my sister used to call me bro. Bro. Okay, my mom used to call me son. My girlfriend used to call me darling. Okay, now just understand carefully. This is the main object. Main object reference variable. Reference variables are friends, sister, mom, girlfriend. I am the object. I am the object. Okay, fine. Now let's make some modification in the object. Okay, fine. So one day my sister told me, get a haircut. Okay, one day my sister told me, get a haircut. Okay, I go to the barber and get a new hairstyle haircut. Okay, that means the object got modified. Okay, the object got modified. Now, that modified object is visible to only my sister or all the reference variable. Tell me. Tell me. Suppose initially I have a old haircut. I have a old hairstyle. Okay, I go to the barber, get a haircut and a new hairstyle. Now that is visible to only my sister who has commanded me to get a haircut, or all the variables which is pointing to me. The new hairstyle is visible to all the reference variable. Fine, fine. So that means if suppose if suppose if an object is pointed to more than one reference variable. Okay, and if the object is changed by any one of the reference variable, then it is visible to all the other reference variables. Get a point? It is the most important concept. If the object is modified by any one of the reference variable, then that object is that modified object is visible to all the other reference variable. Fine. Okay. But 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 first let's see this in code. Fine. Uh, and I'll give you one question, so you need to solve it. Okay. Fine. So let's see this in code. Okay, so here is my Eclipse. I'll create the string A equals yes. Okay, string B equals yes. Okay, now just answer in the comment box. Okay, okay. A equals yes, FAANG. Okay, A, B. Answer. Answer in the comment box. Simple. Let's draw the memory allocation graph. Okay, yes, it is created using direct literal way. Okay, so it will not create another one. Fine. A equals Yash Fang. So this is also direct literal. Yash Fang. It is pointed by A. Now A is not pointing to Yash. A start pointing to this. If you print this, so answer is Yash Fang. And this is also Yash. Okay, so let's see the output. Fang and Yash. Okay, next. Next is okay. Yash AB Fang. B equals A. Okay, and Yash uh, IBM. Okay, now tell me the answer of line number 9 and line number 10. Simple. Draw the memory graph. Draw it. A pointing to Yash. Okay, now it will create another string in the string constant pool. See, these two strings are created using the direct literal. Okay, then definitely they will go to the string constant pool. But they are two different strings. So they both will create two different space. Yash farm. Okay, pointed by B. B equals A. That means now B is pointed to A. Okay, B is not pointing to Yash farm. B is pointed to A. Okay, and A is pointed to another literal Yash IBM. After executing this line, Yash IBM, which is pointed by A. So if we print it, so this will print, and after executing this line, B is pointing to Yash. Okay, so for it will print Yash IBM and then Yash. Let's run it. See, I hope you got the understanding. Okay, so just draw the memory graph. Okay, and you'll get a good understanding. Fine. Now, the most important topic of string is immutability. Immutability. Okay. Okay. So I was talking about the concept that if this is an object, if an object is pointed by more than one number of variables, more than one number of reference variable, and if that object is modified by any one of the variable, then that modification is visible to all of the reference variable which is pointing to that, which is pointing to that. Okay, fine. I'll tell you the garbage collection also, okay, at the end of this video. Fine. But the twist is this feature strings don't have. Why? Because optimization due to security. See, you can't change strings. You can't change strings. I've told you the object is modified. The object is changed. But in case of strings, you can't modify the strings. Never. Strings are immutable in nature. And the concept is immutability nature of strings. That is our next topic. That is why I explained you this example. Strings don't have, but string builder have the modified. Okay, suppose if you have to change the string, if you have to modify the strings. So the next class, the next video, string builder and string buffer. Okay, we will see. First strings. Fine. So open a notebook. Immutable. I'll show you while in code also. Fine. That why I'm telling that strings are immutable nature. Nature of string. Okay, I am not telling in a like air that okay strings is immutable. Fine. No, I'm gonna prove it. So why I'm telling this? That why I can't modify the strings. Let's see. So this is a two strings. Okay, let me create one string only. This is a string I created. If I print it a, then I'm getting same. Now I need to modify these strings. How I can modify these strings? By adding some other strings. Suppose my name is Yash. Okay, how I modify that name? By adding another name. Okay, that is only the way to modify. Okay, so there is a method in strings, and using plus operator also you can modify. But there's a method concat. Concat means add, attach. Okay, attach, combine. Okay, so a dot concat. Okay, and the string which you want to combine, just write that string. Suppose I write IB. Okay, now the original string is Yash. Okay, the original string is Yash. I have added IBM. So now what A become? Yash IBM? Definitely. Just try to print it. A. Yash. It has not modified it. Why? Let's see using memory allocation. That is why I see memory allocation is most important topic. This is stack, this is heap. Okay, not here. Let's see in our whiteboard. Okay, let me take this thing, my current page. Okay, fine. So let's draw the memory graph of this. It is a stack, it is a heap. stack and heap. Okay, this line, after executing this line, A, there is a constant pool in which Yash is created. Okay, why? Because a string is created using direct literal. Okay. Now A dot concat B. So this line is concatenating, that means adding another string. Yash is one string. It is concatenated IBM. Okay, another string. After executing this line, this string is itself created. Yash IBM. Okay, Yash IBM. Fine. And then we are printing A. A is pointed to Yash, not Yash IBM. Fine. Now, if A equals, now that string, okay, is pointed by A. That means now A is not pointing to Yash. A start pointing to Yash IBM. Data point. Now run it. Yash IBM. A is pointing to Yash IBM. Fine. So this is what all about immutable nature of strings. You can't change strings. You can't change. If you have to change the strings, you need to use string builder, which is our next topic, next video. String builder and string buffer. Okay. This is what the immutable nature of strings, the most important. Okay, fine. The next thing is, the next thing is if strings are created using new operator, then there are two ways to create strings, right? Two ways. Direct literal and new operator. We have seen direct literal. Now the new operator. Strings A equals new strings Yash. Fine. And string B equals new strings Yash. Fine. Draw the memory graph. Okay. So this is the stack. This is the heap. Stack memory, heap memory. Okay. Now, if you create strings using new operator, it will follow this rule. This rule. Rule number one. Actual value or object is going to take place in heap memory. That means it will actually that string SCP also in heap memory, but it will not go in SCP. Okay. If you create the string using new operator, it will not go into a string constant pool. It will create two different. Why? Because using new operator, we are creating a new object. New object. See, if you are creating the string using direct literal, okay, direct literal, you are not creating a new object. It's a value. Okay, it's a value. Yes, is going to take place in some memory. But new operator is going to create a new object on which you can call something else. Fine. So this is the stack. Yes, B, yes. This is the correct memory management when you create the string using new operator. Fine. So string A equals new string. Okay. And yeah, so let's print it. Fine. Okay. Now let me give you one problem. Okay. Fine. Okay. Tell me the answer. Comment down the answer. Comment down the answer. Okay. So let's solve using memory allocation. Okay. This is the stack. This is heap. Stack memory, heap memory. Fine. Initially we have created A using new operator. Okay. Yes. B using direct literal. Direct literal value goes in string constant pool. SCP. String constant pool. B equals FAANG. We have created another literal. Another literal. Okay. FAANG. Now B is pointing to FAANG. A equals B. Okay. Now A is also pointing to FAANG. B. Print it. A. FAANG. A is pointing to FAANG. Okay. B. Now another literal A. IBM. Another literal IBM. Pointed by A. Now A is not pointing to it. Okay. A is now pointing to IB. A. IBM. B is still FAANG. FAANG, FAANG, IBM, FAANG. Let's run it. FAANG, FAANG, IBM, FAANG. See, super easy using memory allocation. How important is this? How important is this? The most important part of string is memory allocation. I'm telling you. Okay, so this is what the memory allocation. Fine, fine. Okay, so we have done, and the few problems also we have done. Okay, the remaining thing is methods, right? Using new operator. Okay, fine. Immutable nature. Okay, we have done the great real world example. Fine. Rules. Okay, got it. Now the next thing is compare the, or I can write how we can compare the two strings. First, using equals equals. Second, using equals method. What is the difference? Let's see using code. So, okay, let me create two strings. String b equals new string. Okay, tell me the output. True or false? Is a equals b or not? Both are yes. Run it. False. Why? Memory allocation. See. Let's draw the memory allocation graph. Stack heap. A, Yash, B, Yash. Okay. A equals B. It is giving me false. That means that means equals operator is comparing these two. Equals are not comparing the values. Equals comparing the reference variable. Let me do one more experiment. Okay. If B is also pointing to A, C equals comparing the reference variable. These two reference variable are pointing to two different. Now if I'm pointing B to the A, same value, then see the magic. True. Why? Because now B is also pointing to this. So now it will compare if A and B is pointing to the different value or same value. Same value. So it will give true. Fine. Got it? Compares compares the reference variable and check whether they are pointing to different values or same. Okay, now equals will compare and check the values. Okay, suppose okay, I erase this. So I write equal then it will give false. Okay, now dot equals parenthesis inside B. Okay, A equals B. True. Because it is comparing these values, not the reference variable. Fine. This is what all about the equals method. Okay. So your task is to check each and every method. Okay. A dot C caret. Now caret is doing like if suppose you want the particular character at index. So what is doing is suppose A dot caret 0. Suppose you want the zeroth index of the string. So YESHE 0, 1, 2, 3, 4. Zeroth index is Y. Okay, you print it in caret, you get Y. Okay, so the your task is to check each and every method. Okay, I'm not going to show every method. See concat method to combine. Okay, code point at int index. Find chars contains, see contains method, and you can see the description here. Okay, the description here, and hash code. Fine, last index of. Okay, fine. So this is your task. Okay, you need to do it, and this is what all about this video. And I hope you got a clear cut understanding. If you got a clear cut understanding, then please comment down. Okay, please comment down that yeah, we got the memory allocation concept. Fine, please comment down, and if you like the video, then please subscribe. Okay, thank you.